Welcome to the AI Research Roundup. I'm Alex. It's May 7th, 2025. Today, we're diving into an ICLR conference paper published a few months back on January 22nd called Do LLMs Recognize Your Preferences? This paper introduces PREFEVAL, a benchmark to test if LLMs can truly follow our preferences in long, multi-session chats. So it's all about improving chatbot personalization, which is often lacking. Okay, so this first figure really lays out the PREFEVAL setup. It shows the multi-session conversation flow, how user preferences are introduced either explicitly or implicitly, and then the tasks used for evaluation. These include generation, like giving advice, and classification via multiple choice questions, with an LLM-based evaluator checking for specific error types. This structure is key to testing that preference following. Building on that LLM-based evaluator, this table details the error type aggregation rules. It shows how different combinations of checks, like violate preference or hallucinate preference, classify errors into 4 distinct types. For instance, a preference-unaware violation is when the LLM ignores a preference it wasn't aware of. This systematic classification is really important for understanding how these models fail to follow our preferences. Okay, so this set of graphs compares 5 methods across 6 LLMs on the generation task. We see accuracy plotted against conversation length. Zero shot, which is just direct prompting, performs poorly. Reminder, a specific prompting technique, and RAG, or Retrieval-Augmented Generation, which pulls in relevant information, generally show higher accuracy. However, even for these, performance tends to dip as the context gets longer, showing the difficulty in maintaining preference adherence. Now, this next figure breaks things down even further, looking at how well these LLMs handle different types of preferences on that generation task. We see explicit, implicit choice-based, and implicit persona-driven preferences. And it's pretty clear. Implicit preferences are just tougher for the models to pick up on, especially with zero shot. The reminder technique helps a lot, but that performance drop with longer conversations is still there. Alright, so this figure offers a closer look at the types of errors these models make. We see pie charts showing error distributions for 2 LLMs across methods like zero shot, reminder, and COT, which is chain of thought prompting. Zero shot mostly leads to preference-unaware violations. Interestingly, other prompting methods, while sometimes improving accuracy, can introduce more hallucination or unhelpful errors, where the LLM invents preferences or fails to respond helpfully. Now, this graph presents a really interesting finding. It shows the accuracy of following the first preference, stated at the beginning, as more preferences are introduced throughout the conversation. Counterintuitively, adding more preferences actually improves adherence to that initial one, possibly by reinforcing the model's attention. These results are specifically for Claude 3 Sonnet, using the reminder prompting technique we've discussed. Building on that idea, this figure compares how adding conflicting versus non-conflicting preferences affects adherence. We see results for Claude 3, Haiku, and Sonnet. The red bar is the baseline with a single preference. Interestingly, even adding a conflicting preference, shown in blue, improves accuracy over the single preference case. Non-conflicting pairs, in orange, also show improvement, reinforcing that more preference signals can be beneficial. So to wrap things up, it's clear that while current LLMs are powerful, they still struggle with long-term preference following, especially for implicit cues. This PREFEVAL benchmark really highlights these challenges. But encouragingly, it also shows that fine-tuning, which is essentially training the model further on specific preference data, can significantly boost this capability. Well, that's all for this AI Research Roundup. Thanks for tuning in.